Okay, hello. So now that we know what a logarithm is, we are going to look at how do we evaluate a logarithm, and that just means figure out what it equals. Okay, so quickly, common logarithms. A common logarithm is simply a logarithm with a base of 10. So log base 10 of 1,000 equals 3. Since our base here you can see is 10, that's called a common logarithm. Now usually it's not written. If you'll notice on your graphing calculator, you have a log button. It is a log with a base of 10, and there's no 10 written. So that is assumed that if there is no base written, that it's a common logarithm. It's assumed that you understand that really there's a 10 there. So this up here is usually written like this. And you'll notice no 10 right there. So this is more the way that we would usually write that. And again, that's called a common logarithm. So if you don't see a base, think it's 10. Okay, and that's your calculator button as well. Okay, so a quick reminder about negative exponents that you saw in the previous lesson as well. Okay, so I want to evaluate some things and just get us used to our thinking. So in our previous lesson, we learned how to convert these. So let's say I have log base 5 of 625. So first I think, all right, well, I don't know what that equals, so I'm going to say it's x. Okay, now using my skills from my previous lesson, I should be able to convert this to exponential form. So 5 to the x power equals 625. Okay, so now I have to figure out 5 to what power is 625? You might not know that, so you're going to go to your calculator and try some things. So 5 to the third is 125. 5 to the fourth is 625. Okay, so there it is. So now I know that 5 to the fourth is 625. Okay, so what does that mean? It means this right here is now, let's actually go to a different color. This actually equals 4, since 5 to the fourth is 625. So that means log base 5 of 625 is also equal to 4. Okay, so that's how those work. So remember, logarithms are exponents, and that's what my exponent is here. Okay, so over here, kind of same process. You're thinking, when does this equal x? So log base 6 of 216, what does that equal? Okay, so really in your thinking, you don't have to write this out every time, but you just might think, convert it to exponential form. 6 to the x power is equal to 216. So what is that? So again, play around on your calculator. You might say 6 to the third power. Boom, right away, there it is. All right, so it's 3. So you're going to go say, well, cool. That means log base 6 of 216 is equal to 3. So I'm going to erase this and put a 3, because I know that 6 to the third power gives me 216. Okay? So this is really what you're doing. You can do trial and error. And it's just thinking, all right, so this one, notice it says log of 1,000,000. There's no base. First thing you should think to yourself is, since there's no base, that really means it's base 10. Okay, so I'm really thinking 10 to what power gives me 1,000,000. Okay, and then you would play around on your calculator until you get that. So let's see, 10 to the fifth is 100,000. 10 to the sixth is 1,000,000. So there we go. Okay, so this means this is equal to 6, okay? Because 10 to the 6 is equal to 1,000,000. Sometimes you get harder problems like this one, which actually you end up with a negative exponent, and this would be -2, which is what we talked about here with negative exponents. But you might not see that one right away, and you might be playing around in your calculator for a little while. So in that case, it's often easier to use the change of base property. And this over here on the left is just saying you can change the base to whatever you want. So I really don't want you to focus on that one too much. I want you to really look more at this one right here. So if you're trying to figure out what a logarithm is equal to, or evaluate in other words, and you're not really sure what to do or what it equals, you don't want to play around on your calculator, you can use this to figure it out. So it says log base b of a is equal to log a over log b. You'll notice here in this section there's no base. That's a common logarithm. They changed it to base 10. The reason they did that is because that's on our calculator. So over on this problem that we have in the right, it says log base 2 of 8. We want to figure out what that equals. Now you might know that in your head. 2 to the third power is 8. But let's pretend like you don't. So how would I rewrite this? I would write log 8. Notice my a is written on top. My a is this one. In this case, my a is 8. Over log b, my b in this case is 2. Okay. So over log 2. All right, so now this might be a little confusing here, so let's kind of go back. So really what you want to think about is this bigger number goes on top. It's a little bit written a little bit bigger. The base is always on the bottom down here when you rewrite it as change of base. And then you're just going to type this into your calculator to figure out what you get. Log 8 divided by log 2. Okay, so you would do that on your calculator to see what we've got. So I'm going to go log 8. Now here you got to remember, don't forget to close the parenthesis. If you do, you're going to get it wrong. Divided by log 2. Close parenthesis, and that's 3. Now that fits with what we had here in our heads. So this is 3. Okay, so this is nice for problems that maybe you don't see it quite as obviously, and you don't always have to use change of base, but it's just a good way to check. So this one, let's practice this just a little bit. Okay, so I'm going to use change of base. So log, I want the bigger number on top first. And by bigger, I mean actually physically a little bit bigger, not the greater quantity. So that 8 number here is written a little bit larger. The bottom number is your base. So our base is 2 here. So it's log 8 over log 32. And you're just going to type that into your calculator. So let's do it. Log 8 divided by log 32. And that's 0.6. Now if you had to do trial and error and probably come up with that, you might be sitting there for a while because you probably wouldn't type in decimals right away. So that's why this is kind of handy. So this is 0.6. Okay, the second one, log base 3 of 9. You might not need the change of base formula here because it's really saying 3 to what power is 9, and you probably already know that that's 2, 3 squared. So you don't have to use the change of base. If it's obvious, go for it. Otherwise, you could use the change of base. You'll still get 2 if you type that in. But problems like these last two, it's going to be easier for you probably to use change of base, and you'll see why in a second. So if I rewrite, oops. Let's go this. Okay, so rewriting this using the change of base would be log 7,000 over log 4. Again, no base, so that means 10. So now I'm going to use my calculator to type that in. Log 7,000 divided by log, I already forgot what it was, 4. Okay. Okay, we get a big long decimal. So we're going to round this to the nearest hundredth, said the directions. So 6.386. Since 6 is 5 or bigger, we're going to round that to 6.39. Okay. Okay, so what does that mean? It means if you were to take 4 to the 6.39 power, you would get 7,000. Okay, that's what that means. All right, so let's try this one more here. Okay, so 2 to what power is a million? So to figure that out, we're going to go log 1 million over log 2. figure out what we get. Let's try it out. Log 6 zeros there, divided by log 2. Okay, we're going to round this to the nearest hundredth, so 19.93. So again, that means back to the original, it'd be 2 to the 19.93 power would give me a million. Okay, so that's using the change of base property to help us evaluate. Okay, that's it. See you later.